Hi, welcome to the second video on Java module and dependency management. In this series, I want to motivate a recipe for setting up Java projects with well-structured and maintainable module and dependency management. For this, I set up a dedicated website where you can find the recipe and also a link to the example I'm using in these videos. Today we focus on the first point of the recipe, which is deciding for a method to declare dependencies in your Java projects and doing this in dedicated files. Last time we took a general look at how modularity works in Java, that an application is a composition of jar files, which are the modules that make up the application. We explored how you can dynamically compose and modify an application by selecting which jar files you include into it by putting them on the class path or the module path. We have also seen that there are many possible misconfigurations. We have seen that Java itself can help you sometimes to discover and resolve these, but that often you would like to use additional tools to help you with this. That's where the build tools Gradle and Maven, which are also dependency management tools, come into play in the Java ecosystem. So before we look at the details, we can say that there are three common ways to declare dependencies between modules in Java at the moment. The first thing is using the Java module system, which is a notation from Java itself that was introduced with Java 9. This is, however, not yet widely used. The second and third options are to use one of the build tools to declare dependencies. Because when these tools were developed, the Java module system did not yet exist. These tools came up with their own notation for dependency declaration. So you have the choice to use either Gradle or Maven. If you go with option 1, the Java module system, you still need to use one of the build tools. It only means that you do not need to use all of the dependency declaration capabilities of these tools, as you can do them in Java directly. You still need the dependency management tooling behind that, for example, for version management. Last time we only looked at compiled and packaged modules. We did not explore how dependencies between these files are defined or which this data is located so that tools could use it. We also did not look at how we define dependencies of our own modules during development. If we look at the set of jar files that make up our example application again, we could visualize that there are dependencies between them. We saw last time which problems may occur if a dependency is missing or if a wrong one is selected. We saw, for example, that the Java module system will inform us if a module is missing that is definitely required at runtime. To understand where Java has this information from, we should take a look at one of the modules in detail. Let's take a look at the Commons CSV module that we already used last time to explore some cases. Commons CSV is an open source library that is published to the Maven Central repository. Maven Central is a repository, a server that allows build tools like Maven or Gradle to access modules following a certain pattern. I talk about this more in my Understanding Gradle video on publishing libraries. In this repository now, we can find the Commons CSV module that we are using. Concretely, we find the jar file there, but also additional metadata file like a POM file, which is a file in XML format. Before we look at that, let's look into the jar file. In the jar file, we find, in addition to our compiled code, a file called module info class. This module descriptor was introduced with the Java module system in Java 9. It is a Java file with a specific format. A module or a jar file that is fully compatible with the module system needs to have this file. In the file, we now find some information I mentioned last time. For example, a unique module name for this module, which in this case is org Apache Commons CSV. We also find a list of require statements, which means this module requires certain other modules, also identified by their unique name, to compile and run. In this case, the modules are Java SQL, Apache Commons Codec, and Apache Commons IO. The Java SQL module, which we don't see here in our shelf full of jar files, is the so-called Java Core module. So it is delivered with your JDK, and that's why it's also not visible as a separate jar file. If you require it, Java finds it inside the JDK installation. And this is the information Java is using if we use the module system to inform us that a module is missing before it is even starting up. You may remember, if we do not use the module system, by using the class path parameter instead of the module path parameter, Java will not give us this information, but instead error out with a missing class. This is for backward compatibility. If your application does not use the module system, but the traditional class path approach, or the information that we have in these module info class files is ignored. Which brings me to the next topic. If the module info class file is not available, which is still the case for many Java libraries that are not fully compatible with the module system yet, your build tool, Gradle or Maven, still would like to know the dependencies. That is why years before the Java module system was invented, Maven defined a format together with the Maven build tool and the Maven repository format for metadata that can carry such dependency information. This is known as the POM format. So in a repository like Maven Central, next to each jar file, you will find a POM file. This file contains metadata about the jar file that can be read by additional tools on top of Java. Java itself won't look at this file. One of the most important information in this file are the dependencies. And if we look at it in the example, we find similar information there as we found in the module info file. We find that there's a dependency to Commons Codec and one to Commons IO. Java SQL is not mentioned as it is part of the JDK, so it is nothing that needs to be downloaded from the internet in addition. Commons Codec and Commons IO are referenced by the so-called coordinates. Coordinates are made up of the group ID and the artifact ID. This is another unique identifier for this module. Usually there is a one-to-one mapping between the coordinates and the module name. They are both unique identifiers, just that the one thing was defined with the POM format and the other thing with the Java module system specification. What you find in the POM file though as additional information are versions of the dependencies. This can already help us with one of the problems we saw last time. That was we selected the wrong version of Commons IO. Now the version information here states which version is compatible with Commons CSV. Likely the version that was used during compilation of Commons CSV. So in summary, we see that there is quite some overlap between the additional metadata for external tools and the module info metadata. But the information about versions is an important additional information in the metadata outside of the jar file. This is because the tool can use this information to get the right version for us. So if you would imagine a very simple project that only depends on Commons CSV and you use that with a build tool like Gradle or Maven, the build tool will likely get you all the dependency it needs automatically because it knows all the information from this metadata. I switch this repository view here to no longer show us the Maven Central repository with binary compiled components to our source repository. This corresponds to the project I have on GitHub. So now we see here a file tree with our source code and our module definitions in it. In my tool here, I can switch between different representations of the module definition. You remember there are the three options, using the module system, using Gradle or using Maven, so that I can show you the different definition styles that are commonly used today. Some details such as additional configuration files for the whole setup are omitted from the view here in the video. If you get the complete project from GitHub, all files you need are there. If you want to know more about which other configuration to put where in a Gradle project, you can take a look at my Understanding Gradle series. And we will also get to some more build configuration topics in the next videos of this series. You may remember that the example contains 6 modules I developed myself, which are the modules in the 2 top shells, which is a game engine called JavaCar and a game using that engine called GemCatch. As example, let us take a closer look at the GemCatch Actors module, which is the one that has the dependency to Commons CSV that we just looked at. Here we can take a look at the module info Java file. And here, just as we saw in the published module, we can define what our module requires in terms of module names. So we say that our own module GemCatch Actors requires our own JavaCar model module and the open source module Apache Commons CSV. The module info Java file is also used for some other aspects that the Java module system brings us, which is the ability to make packages visible or invisible which I do here via the export statement, and to register service providers, which I do down here, which is the mechanism that allows us to dynamically load and exchange modules. In this series, though, I would like to focus on the dependency declaration aspect. Now, if this is a Gradle project, each of my modules should also have a build Gradle or build Gradle KTS file. These files could also be used to declare dependencies. Now, as I use the module system, I already have this information in my module info Java file. I can tell Gradle to get the dependencies from there. Then I don't need to declare them again here in the file. We can do that by using the GradleX Java Module Dependencies plugin that I co-developed. And now, if I want to use Maven instead of Gradle as build system, I can do the same. In Maven, each module should have a POM XML file instead of the build Gradle file. And this file has a build configuration for Maven in XML format. For Maven, I have ported the Gradle solution to extract the dependencies from the module info file. For this, you need to use the Java Module Dependencies Maven extension. The nice thing with this solution is that the build Gradle or the POM XML files are almost empty, which means you define your modules in pure Java. All other build configuration is extracted to a central place in the project structure. This will be a topic in one of the next videos, but for Gradle I already cover this in detail in the video on convention plugins. This is also a very good starting point if you don't use the module system, which is the case for most projects today. Then you want to use the build Gradle file or the POM XML file to define dependencies. The good thing is though, if they don't contain other build configuration, they are exclusively used for dependency definition and are kind of similar to the module info Java file, just in a different format. So if we use Gradle without the Java module system, the module info Java file will be gone and the dependencies would be declared in the build Gradle file like this. I also have a detailed video on this topic where I also talk about the scopes that you can use which influence the visibility of dependencies at compile time. Switching to Maven, the same dependencies would be defined just in the Maven XML format, which looks like this. We can see that in both Gradle and Maven, the coordinates notation, so the combination of group ID and artifact ID, is used to refer to other modules. As in these cases, not all modules might have a unique module name when the module info Java file is missing. In Gradle, you can also use the short notation for local modules with the keyword project and then only the artifact ID. In the end, it's still similar to what you do in the module info file. You refer to the modules you depend on or the modules you require by their unique names. Also, the module info file can have scopes, so there is require, for example, and require transitive. I also have a video that goes into more details on that topic. You might notice that now in my dependency definitions, I also did not define any versions. This is needed, but one point of the recipe is to keep this information out of the files that you dedicate for dependency definition, which is either the module info file, the build Gradle file if you use Gradle without module system, or the POM XML file if you use Maven without module system. The versions of third-party dependencies is something you should also define centrally for your project and share among all your modules. In my case, the 6 modules the game and the game engine is made of. How to do this and where this central place can be is the topic of the next video. In any case, the example already contains all the setup. So before we close, we can have a quick look now how the dependency information is used by the tools. If we run the Gradle build, we can now see how Gradle selected the modules here that we need to get a running application. Information such as which transitive dependencies are needed or which jar for which operating system needs to be selected is now done by the tool. We explored the first point in my recipe for carefree dependency management in Java projects. It is about declaring dependencies in dedicated files. Most projects that do not use the module system define dependencies either in the build Gradle or POM XML files, which often leads to dependency definitions being lost in a lot of other build configuration noise. It seems to me that it is often forgotten that the build tools are also dependency management tools and that you do dependency definition through these tools if you don't do it in Java itself. But the existence of the Java module system alone shows that this dependency definition is part of the development of your modules of your software, and not just some build configuration for building and assembling the software. So in my opinion, it is very important to separate this from other aspects of the build configuration. It's also something all developers of a project should be aware of and work on, because the module structure of your project, if it is well and healthy, will always be in flux, while other build configurations might be stable for months or years. That's why if you have the opportunity to use the module system as I showed here, I would give it a try. It allows you to do a cleaner separation of dependency definitions because they are written in Java itself, in a standard Java syntax. It doesn't even matter which build system you're using under the hood then. And also, if you can't do that, look at your Gradle or Maven setups and check if you can separate out dependency definitions from other aspects of your setup. We will look at approaches for doing that in the next episodes, starting with how to define the versions of third-party dependencies in a dedicated place. See you next time.